Okay, so here's the AP packet, and I'm just gonna give you a few pointers on some of these questions. And let me start with question number 2. The graph of the function, or the graph of which function has y equals -1 as an asymptote. Notice that it doesn't say whether the asymptote is a horizontal one or a vertical asymptote. But the fact that it says that it's the line y equals -1, that makes it a horizontal asymptote. Because isn't that the equation of a horizontal line? So how do you know which of the 5 answer choices has the horizontal asymptote of y equals -1? Without graphing them, of course. Well, we took some notes on horizontal asymptotes, and we said in class that if you take the limit as x approaches infinity or negative infinity of the function, then that's the way to find the horizontal asymptotes. So you're going to have to do or take the limit of each one of these as x approaches infinity. And if you get -1 for one of them, then that's how you know you found the right answer. So I'll take the limit as x approaches infinity of -x over 1 minus x. And I'll do it for each one of them until I find one that has -1 as the limit. And that's all I want to say about that question. Well, maybe I should add that for part C, this is the ln of x plus 1, and when you plug in infinity, you're going to get infinity plus 1. Let me just try this one for you. The limit as x approaches infinity of the ln of x plus 1. So when you plug in infinity, you'll have the ln of infinity plus 1, which is the ln of infinity. And the ln of infinity just means what do you have to raise the number e to in order to get infinity? Or e to what power gives you infinity? And the answer to that is infinity. So the limit does not exist. And since there's no limit, then this one doesn't have a horizontal asymptote of y equals -1. But you can go ahead and try A, B, D, and E. The other question we can look at is number 3. And here, if you plug in a -3, you'll notice that you'll get 0 by 0, a removable discontinuity. So try and factor out. You can factor out the numerator and get x times x plus 3. When you factor out the denominator, it'll be square root of. That also factors out the inside to x plus 3 squared. And continue, the limit as x approaches -3, x times x plus 3. Most people will say that the square root of x plus 3 squared is just x plus 3. But in reality, the square root of a quantity squared is plus or minus that quantity. This is a property. It's called the square root property, and if you were in my pre-calc class, we talked about the square root property quite a few times. And this is important that you have a plus or minus, because now the x plus 3 will cancel out. That leaves you with the limit as x approaches -3 of x over plus or minus. I guess we could say that's a plus or minus 1 because everything else canceled out. So that is the limit as x approaches -3 of plus or minus x. That's what you get when you divide x by plus or minus 1. And now you can finally plug in the 3 and you'll get plus or minus negative 3. But plus or minus negative 3, that's just plus or minus 3 anyway. And the thing to keep an eye on is that you have two answers, and a limit cannot have two answers. So the answer to all this removable discontinuity is that the limit does not exist. I can tell you about question 4 that, see how there are three functions, f, g, and h? There are two answers to the question, so there will be two functions that work based on that question. And I'll let you figure that out on your own. Number 5 says a population grows according to the equation P of t, and you have the equation for t greater than or equal to 0. This population will approach a limiting value, and one of your classmates came to class came after school for tutoring, and he tells me that in the environmental science, AP environmental science class, they call this limiting value the carrying capacity of the system. And because this is a math class, they just called it a limiting value. And so you have a population given by the function, and then the question says, during which year will the population reach half of its limiting value? Before I can figure out when it reaches half of its limiting value, I want to know what is the limiting value so that I can get half of it. And to answer that question, you need to know the basics of population growth. So populations, or any population, usually starts with a few members in the population. They'll reproduce, and then they'll grow, and it'll level off eventually, and that becomes the limiting value. So as time goes on, the population can only sustain so many members because of the environment. And when you think about it, that's a horizontal asymptote. And how do we find horizontal asymptotes? We take the limit as, in this case, t, because there's no x, this is a time variable. The limit as t approaches infinity. And what are we taking the limit of? Your population, which is 6,000 minus 5,500 e to the negative 0.0159 t. And when you take the limit of this function, you'll just get 6,000 minus 5,500 e to the, think about what you get when you multiply negative 0.0159 times infinity, because that's what t becomes, infinity. So if t is infinity and you multiply it by a negative decimal, you'll just get negative infinity. And what does that do to the expression? Well, negative exponents, remember, just rewrite them as positive exponents. So this is over e to the positive infinity. And e to the positive infinity is a large number. So we can just say that's infinity. And 5,500 divided by infinity will be 0. And then 6,000 minus the 0 is just 6,000. And that's your limiting value. Which means the population can only sustain 6,000 members. And even if time goes all the way to infinity, the most you can have is 6,000. So now we can continue with the question that says, during which year will the population reach half of its limiting value? Well, if the limiting value is 6,000, half the limiting value would be 3,000. So what we have to do now is say, take 3,000 and set it equal to the population, which was 6,000 minus 5,500 e to the 0.159t. And to answer, to solve this equation, you need a calculator. And on the calculator, I would just call this y1, call this y2, and you are looking for the intersection. So you would do a second trace intersection. But I'm really not concerned about the answer. I really do want you to just know the process. So if you're able to follow what I'm saying, you're okay. Don't worry about getting an answer to this question. And don't worry about the test having a question like this. We'll keep it simple. And I just realized that I made a mistake here with my exponent. It's not 0.0159, but 0.159. It's not going to change anything. It's just move the decimal. Everything else would still be okay. I'll stop the video now, post this video, and maybe work on another.